PhD. I'm second year PhD, work with Dr. Donald Williamson on audio enhancement.
I'm a second year PhD in engineering department. Was currently working with Professor David Crandall related to the computer vision and the deep learning task.
I'm Wenhao. I'm the first year master student here at IU. So.
Yeah, my name is Miao Jiang, and I'm the third year PhD student. Generally, I work with Dr. Geoffrey Fox and Dr. Judy Q. We work on high performance computing to solve some machine learning problems.
Yeah, I'm Yuchen. I'm a graduate from engineering department, and my advisor is Professor Feng Guo. Our project is focused on the bioengineering.
Okay, so today we're present our project proposal. We're trying to do adventure control simulation. So first, we're going to go through the overview, the project description, the design content, and test and deliverables. So we're trying to design and implement a fourth-floor adventure system that unites the state machines and use 7-segment display for the adventure display. So the 7-segment display is a form of electronic display device for displaying decimal numbers that is an alternative to the more complex dot matrix displays. The display works by emulating appropriate segments to create a letter or number. Use the 7-segment display for non-ASCII characters by simply setting the appropriate segments.
The reason why we would like to think about doing this kind of implementations, normally we guys will handle with some kind of high-level language like Python or even language C will help us finish all the tasks, just print the numbers. So this time we would like to implement from the really low-level things to see how it really works, and to show what we've learned from this class, because such as this kind of vlog is really new to all our guys. So we would like to show, I think this is one of the ways to show how we learn from this class and the related projects.
So for this situation, let's suppose there is a building with there is a 4-floor building with an elevator inside of it, and at first the elevator is loaded with some container, and there is a person at. Let's suppose that this person is at the 4th floor, and he pushed the button and to call for the elevator to arrive at the 4th floor. Once the elevator arrives, and this person will take out the container and just go away. The elevator will stop at the 4th floor with its door open. It won't go anywhere until there's another person pushed for example, at the 1st floor, push the button to call for the elevator to arrive here. The elevator opening and the closing process will take 1 or 3 seconds, and the traveling process will also take the same time. So we want to use the 7-segment system to simulate this traveling process.
Mostly just as they mentioned that we will implement the whole project with a very lot. So generally we may have different modules. First what we call the elevator controller. The elevator controller actually it is about state machine. State machine just means that okay, the elevator may have different status. For example, it can stop, it can go, and it can the status can have just like waiting, but because the door will open and closing, so we need to transform from one state to another state. So we need to make a controller to help the elevator move from one state to another one. So to do this, we need to just like create create a table, just like we may create a table and then we program it according to the table. The second thing is, of course, we need to have a driver to display the 7-segment. Actually, 7-segment programming is a very popular one in the logic gates. I think a lot of people may have see the problem. For example, the 7-segment, it is just like we need to divide a string. It's just like, let me see, 1, 2, 3, 4, 5. Oh yeah, with 7-segment. If we just want to just like show the number 1, it is just like we just show the most right 2 segment. If we want to do 2, we may just draw a picture and just like to let the corresponding ones to be 1, and for the other segments we turn them to 0, so we can just show a 2. However, a little bit difficult thing is that well, we need to show some numbers according to the status. If, for example, if we want the elevator to go to floor 2, we need to show that want the segment to show number 2, or to show if the elevator go to the 3rd floor, we need to show floor 3. We need to make a driver either to control the output for the number. Also, we need to make it correspondent to the status. Another thing we need to do is we need to have a driver to control the time. So we call it a slow clock driver. It is because we want to make the frequency a little bit slower. Because for example, if the elevator go to a certain floor and we need to give some time to open the door and to close the door, we need to just like to make the clock a little bit slower to wait for it.
So the last section we have is text and deliverables. So first of all, our test plan is that ready a Verilog test bench for different small sub-modules and test all the possible outcomes. And then also there will be a test bench for the main file that was testing the whole project. After testing bench testing, we have going to have testing the real FPGA board. The reason why we have test bench first before we testing the FPGA board is because the synthesis for Verilog is very slow. We want to make our debugging process that be more efficient and fast before we really test on the FPGA board. The test result will be recorded and using it later for the test summary report. The test summary report going to include 3 sections: project overview and test procedures and interpretation, and the test result. So the project overview just going to including this short summary for the whole project, and then an explanation for why we're going to test this, and what's the possible income and outcomes that going to be. For the test procedures interpretations, that we can explain how our program works to testing all the result, and the test result is going to prove that if our program works or not. So yeah, that's it.
For me, this is can you go back to last Pyrrhus? For me, this is a less than 2-person project. I mean, there's no difficulties in this project at all. I have already presented the 7-segment display driver in my class. I give you one example. I will present the so-called finite state machine in the future lectures. I don't think this is a 5-person project. Two of 5 people are working on so-called machine learning, why don't you guys, pick up some topic on the machine learning part?
Yeah, we were kind of using part of the machine learning. Actually, the thing is for the elevator controllers, we were designing two patterns. So one pattern basically which we think like a policy or so-called hard-code policies. It's like we will enforce some hard-code policy to make it work. So another kind of testing will be use reinforcement learning to learn the model for the elevator controllers. The reason why I think it will be work is like the state for the elevator controller is really kind of simplicity and clearly. It's kind of you can each time give it a reward. It depends on what will be your next choices based on your status and your policies in your current states. So this is kind of best examples for the testing on a simple reinforcement learning policies here. So we would like to see if it is really work or even work better than our human designs policy for the elevator controller part. But the reason why we were kind of confused that we hope it will be more related to this class instead of just implement deep learning work to show our things. Because, for example, for me, normally I will just use this kind of package for deep learning and do different maybe convolution neural network or RNN to these things. But it is really hard to show our work in this class.
You can actually implement a FPGA or hardware circuit for the reinforcement learning, right? Because when you predict the Q value, you need to do some inference.
Yeah.
You basically can implement a neural network accelerator or convolutional neural network accelerator.
Yeah, and we will definitely compare that with our traditional way to see what's the difference and if it's really worth to do that in the control. And we will show our work for the reinforcement, which you mentioned, that how to do the inference for the Q tables in the controller part.
Who will generate the so-called traffic?
Yeah.
Who will generate the traffic? The traffic means, which one will appear in how many floor, will give you the traces of the elevator. Who will give you the traces of the elevator?
Actually, the thing is, we will basically first you mean how we will get the original data for our reinforcement?
That's right.
Right.
That's right.
The thing is, basically, first we can think about to get it's kind of simple experiment because we have choices of several buildings around the campus. So we can definitely do the testing and get the results how the real elevator controller did in our real lives. That kind of collect the data will be tested because we have 5 people, so we can collect enough data. For example, in 1 week, we just need some people stand there to see what happens for this elevators operating and mark down what exactly is a real elevator controller will did inside things. And also we can also manually to create some kind of conflict. For example, if 2 person or more person click on the requirement on different levels, and if we only have 2 elevators, for example, in the lobby halls, what will happen?
The so-called reinforcement learning based elevator controller seems very fancy to me. Are you serious about this project?
Yeah, actually, I'm serious, and I would like to show my work for learning this class too, because I'm hard to say I'm an expert in reinforcement learning, but I do some real project in reinforcement learning. So for the idea part, it's kind of solid, but I'm kind of worried about the implement for in very, very long things. That's my technical issues we would like to
at least you need to guarantee you can actually compute a inference for the reinforcement learning based controller by the Verilog or VHDL.
Yes, that's one of our concerns, because we will just discuss this project like in short times, and I've never do too many implements in the Verilog because of the hardware.
I provide you 2 options. The first one is to provide more details and more concrete plan on the reinforced learning based elevator controller part. The second one is just do this one maybe by one person or two. All the other members in this group need to figure out another topics.
Okay.
Thank you.